Metrics are going to be used by our router to determine what is the quickest and fastest way to get to the various destination networks it learns about. However, metrics are only going to be compared for the exact same routing source. What that means is that if I learn about a destination network through a routing protocol like EIGRP twice, well, then I can use the metric to figure out what is the quicker way to get there. What if I learned about a destination network via RIP twice? Same destination network via RIP twice. Well, then I can use hop count, the metric, to figure out what is the quicker way to get there. What about OSPF? What if I learned about the same destination network, like 10110/24 from OSPF twice, coming in two different interfaces? Well, then I can use my metric, the cost, to figure out what is the quicker way to get there. But let me ask you this question now. What if I learned about a network like 172.17.8.0 from two different routing sources? Let me repeat that if you missed that. What if I learned about the 172.17.8.0 network that we see right here from two different routing sources? Notice EIGRP told me about it. OSPF told me about it. Are they going to use their metrics to figure out what is the better way to get there? No. No. Why not? Why not? Because EIGRP uses bandwidth and delay. Combined together, we call that the feasible distance. OSPF just uses bandwidth. And EIGRP's calculation is done completely different than OSPF's calculation. It's like comparing apples to oranges. So no, we can't use the metric to figure out who's better here. Not at all. So how do we ultimately determine what is the better source of information? Even before we look at the metric. Let me repeat that. How do we determine the best source of information before we even look at the metric? That's right. I have to play rock, paper, scissors here to figure out whether EIGRP is better than OSPF or OSPF is better than EIGRP. And I'm not even taking metrics into consideration during that game of rock, paper, scissors. So what ultimately determines who's better? It's called administrative distance. And you can see down here that EIGRP has an administrative distance of 90. OSPF has an administrative distance of 110. RIP has an administrative distance of 120. It's listed right here. Connected routes, directly connected routes, have an administrative distance of 0. Static routes have an administrative distance of 1. So notice how different sources of routing information, different sources, directly connected versus static versus RIP versus EIGRP versus OSPF, all have different administrative distances. Lower is better. Now, don't confuse this with metrics, okay? These are numbers assigned to these sources of information that help them determine who is better than who. That's right. Lower is better. EIGRP's is 90 by default. OSPF's is 110 by default. Who's better? Who's better? Lower is better. EIGRP's better. So what goes in the routing table? The one from EIGRP. How do I know this is the one from EIGRP? Look at that next top IP address. It's the same. It's the same. So we're definitely using the EIGRP path in order to get to 172.17.8.0. Now, is that the best path? Well, according to administrative distance, it's the best source of routing information. Doesn't necessarily mean it's the best path. You see, that's the problem here when we learn about the same network via multiple sources.